How can we communicate with doctors and medical experts as a data scientist and convey our meaning to them? If we want to build a model for disease prediction based on clinical characteristics, demographics, signs, and symptoms, what model should we choose to better explain it to them? Do they need to know data science and data analysis to understand the performance of our model? These are questions that I will answer in this video. Choosing the appropriate model depends on various factors such as the model's performance in classifying new data, the speed of model training, the speed of applying the model to test data, memory consumption, the amount of data required to prevent overfitting, and so on. However, here I want to emphasize another important aspect, which is the model's interpretability and understanding the events that occur within it. Models can be categorized into two types, white box and black box models. Black box models, such as neural networks, often have competitive and effective performance. But it is not easy to explain the events that occur within them to those who are not familiar with data analytics and neural networks. On the other hand, white box models such as decision trees and other rule-based models are based on a diagram or set of rules that can be easily explained if observed. Understanding these models is much easier than black box models, and they often have acceptable performance in many cases. So, my recommendation is to start with white box models, especially decision trees. You can easily plot a small-sized diagram of the tree and explain its rule to the audience. The audience doesn't need to have knowledge of data analytics or machine learning to understand the decision tree, and they can easily connect with it. Even the importance of variable and how they impact the output can be understood from the decision tree. Here is an example of a small-sized decision tree. We want to make a model for patients suffering from breast cancer and predict it whether cancer recurrence will be happen in the future or not. For this purpose, the dataset from UCI repository is used and a decision tree is trained on it. We limited the maximum number of leaves in the decision tree to 6. You can see the diagram of the decision tree. At the root, degree of malignancy of the current tumors is considered. If the degree of malignancy is lower than 3, the left branch is chosen, and otherwise the right branch is chosen. Let's talk about one of the rules can be extracted from our decision tree. If for a patient we have the degree of malignancy is lower than 3 and tumor size is not between 10 and 14, then the class label is no, and it means that recurrence will not be happen. In the next video, we will talk about challenges related to decision trees and how to solve them.